Hello everyone, my name is Aditya Gupta and today I'm going to present a project on FNN versus RNN model. The training and the testing of these models is based on the SNL-DLL dataset. So let's go to the code first. So for this task, we're gonna perform binary classification. That is, we are determining whether a data packet is normal data packet or an attack type. And the second is we are going to do multi-classification. In multi-classification, we are going to further identify whether the attack type is DDoS attack type or a probe attack type or any other. So basically, there will be 6 classes which will be identified in multi-classification. So let's go further. First, we're going to see how the binary classification program works. So as you can see, this cell is for extracting and doing the pre-processing of the data. This is the main cell. The program is going to start right from this point. First, we're going to define the number of epochs that we're going to perform, then the batch size, then the file paths, and this is the list of the number of features that we're going to use to train our models. Then from get function, we're gonna get the required data. We're gonna mainly get data type for training the model, then for validating the model and doing a test on that trained model. Going further, first we're gonna train FNN model. So for that, we're gonna call do FNN model function. So in this function, what's gonna do is that we're gonna use a random search class for training our FNN model. So random search class is used for training model with a hyperparameter tuning technique. So what it does is in hyperparameter tuning in random search class, it's going to train n number of models that depend on the maximum trial and the execution per trial. So based on that, it's gonna calculate the n number of models with a different set of hyperparameter values provided by us. So it's gonna train each model, and each model will be trained with the different combinations of those hyperparameter. So after the training has been done, it's gonna return those models and gonna store it as in a list. So after the training, we're gonna extract the best trained model out of those lists. As you can see, using this function, we can extract the best trained model. So once the training has been completed, we're gonna extract the best trained model, and we're gonna perform prediction based on test data set. After that, we're gonna perform other evaluation matrices, like we're gonna calculate a confusion matrix, then we're gonna calculate accuracy of the best model trained so far, and again we're gonna print or plot the confusion matrix. Then at last, it's going to return the accuracy of the best trained model so far. And that return value will be stored in FNN underscore store. Then we're gonna do a little pre-processing. In this pre-processing part, the 2D input array will be converted into 3D type. So its dimension going to change from 2D to 3D. The reason behind is that for the training RNN model, the input dimension for the input data set should be in 3D, not in 2D. So after the pre-processing step, converting from 2D to 3D, we're gonna pass those data to do RNN model so that we can train our RNN model and return the highest accuracy of the best trained model so far. So similar approach has been used in the training RNN model as well. We're going to use random search class, that is the hyperparameter tuning technique to train the model. It's going to again train a number of models based on the maximum trial and the execution per trial. And on each training, it's going to select a different hyperparameters that we have provided and and it will return the list of all the models. And out of those models, we can get the best trained model so far. So after the training has been done, we're gonna get the best model. Again, we're gonna do prediction based on the test data set. Then we're gonna calculate confusion matrix. We're gonna calculate and the accuracy of the model and print those values, and we're gonna plot the confusion matrix as well in this step. And at last, we're gonna return that highest accuracy of the best trained model, and that value will be stored in RNN underscore store. And at last, we're gonna simply print the accuracy of the highest trained model in each of the uh, model function. As we can see for this, the accuracy for FNN model is around 99.72%, while the accuracy for RNN is 99.78%, which is pretty close and fantastic. So, moving on to multi-class classification, the approach is quite similar to binary classification. The first cell is for extracting the data and doing the necessary pre-processing, like encoding and scaling the data. And one more thing, in this case, we're gonna segregate the input data into four more parts based on the type of attack. If it's a DDoS attacks, it's gonna be segregated as A1. If it's a probe attack, it's gonna be segregated as A2 attack type, and so on. So this is the main cell for multi-class classification. Like I said, it's the same approach. We're gonna provide the number of epochs. We're gonna provide the batch size. This is the path for the necessary files. This is the list of all the features that we're gonna use to train our models. Then from this function, we're gonna get the pre-processed data sets, and then we're gonna pass those data sets to do FNN model so that we can train our FNN model and get the accuracy of the best trained model using the hyperparameter tuning class, that is random search class. Then again, we're going to do pre-processing and we're going to pass that pre-processed data so that we can train our RNN model using the same approach. And at last, we're going to print those accuracy value. And for this multi-class classification, we can see the result is that the accuracy for FNN model is 75.48%, while the accuracy for the RNN model is 76.871%. So at last, we're gonna perform the testing of our FNN and RNN model on new data set, and gonna check how's their performance. Almost the same thing has been done in this also. So first we're gonna get the model or the trained model that has been saved from the previous cells. We're gonna extract that using get FNN, RNN models. Then we're gonna get the new test data. Then we're gonna separate and encode it. Then we're gonna scale the value and convert it into NumPy array. And then we're gonna do the prediction on the extracted model based on the new data test data set. Same thing will be done for RNN model. At last, we're gonna print the result. So the result says is something like this. Let's run this program. Just gonna take a few seconds. So see, at last we can see that the accuracy coming for FNN. Sorry for writing it ANN. It's actually FNN. So the accuracy achieved is 41.72%, while the accuracy for RNN is 51.36%. Maybe we run it for more epochs, it's gonna perform better. So anyway, let's go to the questions. So the first question says that we compare the accuracy for the models on the given test data set. As you can see, the accuracy for FNN is 77.92%, while the accuracy for RNN is 73.89%. So this coming to the question two. In my research, I found that LSTM models are capable of holding long-range dependencies. That means it can store the values of all the layers previous to it more than one layer. I mean, it can hold the values from layer 1 and 2 and 3 previous to it. So it can hold the value for more than one layer. Basically, it achieve by creating a memory block. Memory block can be just assumed like a cell block in any standard memory where a block represents and stores a value. Similarly, it also creates a block where it holds the value of the previous layers. Then, if you're going to increase the storage size, that is by increasing how much data or data for how many layers it can store in the memory block. If we increase it from 1 to 5, uh, we will notice that the time taking to train the model, it's going to be quite high as compared to the other models with a lower number of n. Because in higher number is going to store values of that number of previous layers, and it's going to take time to extract and use those data from large memory block. So definitely the performance it's going to be better as it's going to store more data, but the training time will be pretty high. So at last, as we have seen earlier, when training both the models on another data set or the new data set, then this is the result. The accuracy for FNN is 49% in this case, and the accuracy for RNN on new data set is 47.94%. And that's it for this project. Thank you.